All right, yesterday, let's start over, progress quiz 2.6, and I went through and I tried to have a conversation with each one of you about this. A lot of questions that I tried to ask. A couple things to keep in mind is I tried to ask, like, hey, why'd you put a velocity of 0 for your final velocity? Because it might have been okay, but the reason why you did it was maybe wrong. So, like, a lot of these were max height problems. So if you're choosing one of your locations to be at maximum height, then yeah, the final velocity would be 0, and then that would be appropriate. I got too many people saying, well, I put 0 there because you land back on the ground. Or I put initial velocity at 0 because you start on the ground and then you jumped up into the air. That's true. However, we're not talking about while I'm pushing with my legs into the air. We're not talking about as I'm landing and absorbing that impact with my knees. We're talking about only the time in the air. So we're talking from when I just left to just before I landed, because you're saying it's a free fall problem that the acceleration is negative 9.8 meters per second squared. And that only happens when you're off the ground and not touching the ground. So that's after your jump and before you land. That's after the rock leaves your hand. That's after a ball is thrown straight up and it leaves your hand, or you throw a brick straight up and it leaves your hand. So that velocity that we talk about is after it leaves the hand, and the final velocity is going to be right before it touches your hand or it hits the ground or whatever. So yesterday I went through and I tried to answer or talk to each one of you about that. MoreFab 5 was the sheet that was on the cart that should have been the next thing you hopefully got started with. Today I'm going to give you pretty much the rest of the class to work on this one. Some of you got further than others. There's a couple problems, like number 5 on the front talks about sending a laser beam to the moon, reflecting it off like a mirror-like surface, and coming back, and they can do that. And it talks about the lasers moving at constant velocity. It talks about 3 times 10 to the 8th. It's just a scientific notation. If you hate it, you can move the decimal point 8 times to the right, and you get a big number. 300 million, I think, is what it'd be. So that's that. But for that one, it's going to say it takes 2.52 seconds to go from the Earth to the moon, hit the mirror, and reflect back. That's the 2.52 seconds. But the question is saying, from how far is it from here to the moon when the laser went from the moon here to the moon and back? So keep that in mind. For problem number 10, on the back, there's 2 people. There's Pepe the Clown and Babette the Tightrope Walker, and they are 2 separate people that have 2 separate lists of variables. So the key to this one, number 10, is keeping those 2 people separate and making a separate list of variables for each one, and that should kind of hopefully kind of help you figure those out. The only thing that's common about their 2 things, or their 2 variable lists, is the amount of time, because Babette falls for 1.2 seconds, where Pepe jumps up and catches Babette, and they catch each other at 1.2 seconds. So their times are the same, but everything else, they are independent of one another. I think that's what I need to tell you about that. Tests we're going to test on Thursday. I mentioned that yesterday. Things that I for sure will give you to use on your test is Thursday. Yep. Is I will give you a copy of the 5 formulas. So I will give you the formulas, not what you wrote in extra notes. I'm going to give you a copy of the formulas. I'm still deciding on this. I'm not sure if I'm going to give you a copy of this. I'll let you know tomorrow, okay, for the problem types. My hope is we've gotten good enough that we don't need these, but I'm still kind of debating it in my head. So I'll let you know tomorrow whether I'm going to give you a filled-in version of this or not. For sure, yes, I'll give you this. Debating on this one still. So there's that. Tomorrow during class, we'll have some stuff kind of set up as a review. I have a soccer div, and I have a Canvas quiz that are kind of set up to review. The test on Thursday is broken into 2 parts, and from here on out, they're going to be 2 parts. There's something that we call the calculation portion of the test, and it's exactly what it sounds like. It's like the worksheets. that they go through and they give you a set of information and you do calculations to solve for it. Big thing to keep in mind is make sure you put units on your final answer. It's a simple thing, but it makes your answer complete. I do have some stuff built in that if you don't put in the appropriate units, you're going to get dinged a little bit on your answer. We kind of have capped out how many times we'll ding you for not putting the units in, but just putting units is a pretty straightforward thing to do. So meters per second squared, or seconds. Also, algebra. People make algebra mistakes. And I kind of cap that out too. So like if you made an algebra mistake on every single problem, you're not gonna get like, we're gonna max out on how many algebra mistakes you can make and try to focus more on the physics aspects of it, but that is part of doing everything is math. So there's that. Then there's also what I call the concept portion of the test. The concept portion of the test is a multiple choice and or short answer part. People tend to struggle a little bit more on that. I'm going to be upfront with you. The Socrative that I have for you tomorrow is kind of written with that in mind to hopefully help you kind of review and get prepared for that. But it's the ideas that kind of drive our calculations. So like at maximum, a ball is thrown straight up in the air and it reaches its highest point. Okay, and then a series of multiple choice questions. And one of and it might be, well, the velocity at max height is 0. Right, it's a max height problem, and at maximum height it stops. Its velocity is 0. Or it might be, what is the acceleration of that object at maximum height? Well, the velocity is 0, but gravity's still pulling on it, therefore the acceleration is still down at negative 9.8 meters per second squared. Okay, or a car starts from rest and it goes for something, or an object is moving at constant velocity. What's true about the acceleration? Well, the acceleration is equal to 0. Because acceleration is your change in velocity, and if your velocity doesn't change, you're not accelerating, things like that. And tomorrow's Socrative should hopefully help you review some of those ideas too. Okay, so tomorrow I'll give you some kind of review time in class that I've kind of created and prepared for, and then on Thursday we'll go through and we will do the test. So today you have some time to work, ask questions. If you still have some questions on the progress quiz from yesterday, please make sure you get those questions answered, or asked, I guess you should. And then let me know if you get stuck on any of the homework problems from today. Also take a look back and see if you have any other missing homework. Take care of those too. All right?